Hey there, little bio explorers. Hello, everyone. Imagine you walking through a forest late at night. Suddenly, you notice an owl in a tree staring right at you. As you circle behind it, its body doesn't move a bit, but its head turns like a bottle cap, rotating almost a full circle to look back at you. Doesn't it look a bit like a horror scene from The Exorcist? Most humans can only turn their heads about 90 degrees. Any further, and you might need an emergency room. But an owl can actually rotate its head up to 270 degrees. That's like turning from the front to the shoulders, then to the back of the head, and finally almost turning back to the other shoulder. You must be wondering, are their necks made of rubber? Don't the bones inside break? Won't the blood vessels be wrung out like a towel, leading to oxygen deprivation in the brain? Today, let's deconstruct the physiological hacks of this midnight hunter. First, let's look at the owl's neck bones. One of the most flexible parts of the human body is the neck. But actually, just like giraffes, we only have 7 cervical vertebrae. But what about owls? They surprisingly have 14 cervical vertebrae, exactly double that of humans. Imagine if the necks were a chain. A human chain has only 7 links, so the rotation angle is naturally limited. But owls have 14 links. This makes their necks as super flexible as a telephone cord. They can easily achieve an incredible range of twists. However, if the bones can turn, what about the blood vessels? This is where the magic happens. In our human cervical vertebrae, the holes for blood vessels are about the same size as the vessels themselves. If you turn your head too sharply, the vessels get squeezed by bone, leading to insufficient blood supply. But scientists found that the transverse foramina in an owl's neck, which are the little tunnels the blood vessels pass through, are actually 10 times the diameter of the vessels. What does this mean? It means an owl's blood vessels have a super spacious buffer zone within the bone holes. When it turns its head, the vessels don't get stuck. Instead, they have plenty of room to slide and twist. It's like putting earphone wires in a large water pipe. No matter how you bend the pipe, the wires inside won't get pinched flat. And owls even have a more impressive backup gas tank. They have a special structure in the blood vessels near the jaw. When the head turns to its limit and blood flow is slightly obstructed, these structures swell up like little balloons, storing extra blood inside. This is like a power bank for a phone. Even if the main power is temporarily cut off, this backup tank can continue supplying oxygen to the brain, ensuring that while the owl turns its head to find prey, it won't suddenly black out and faint mid-turn. Seeing this, you might ask, why do owls work so hard to train their necks like this? Couldn't they just roll their eyes? That's where nature gets interesting. An owl's eyes aren't spherical like ours. Instead, they are cylindrical, like tubes. These big eyes are like to powerful telescopes, allowing them to see clearly in the dark. But the downside is that these eyes are fixed firmly in the skull. They cannot move at all. So, because their eyes can't move, if an owl wants to look to the side, it has to turn its entire head. For survival, during the process of evolution, they train their neck bones and blood vessels to become this top-tier shock-absorbing and anti-tangle system. In summary, why an owl can become the ultimate midnight hunter isn't just due to its vision, but also this set of 14 cervical vertebrae, combined with the super protective design of loose blood vessel tunnels. Next time you see an owl at the zoo, remember to pay respect to this amazing physiological feature. But definitely don't try to rotate your head like that. After all, our human hardware isn't quite as powerful. If you like today's bio trivia, remember to share it with your friends